All right, so we discussed atomic mass, the mass of an atom. But what if you have a molecule? Well, a molecule, you know, is generally going to involve a number of atoms combined. So a molecule, its mass is going to be the combined masses of all the atoms. The molecular mass is just the mass of a molecule. In atomic mass units, just like with an atom. It's the sum of the atomic masses. So it's the sum of atomic masses. Okay, so say you have sulfur dioxide. Well, one sulfur, you know, has a mass of 32.07 atomic mass units. And you know that one oxygen has a mass of 16.00 atomic mass units, but if you have two oxygens, then the mass that you get from the oxygens is doubled. And so the mass of sulfur dioxide, that's just the combined mass of one sulfur and two oxygens, it's equal to 64.07 atomic mass units. The 32.07 plus 16 again. All right, so moving on from there, introducing the mole. So a dozen. You know, a dozen is a definition of just having 12 of something. But what about a mole? Well, a mole is a very weird number. It's 6.02 times 10 to the 23 of anything. Of something. Okay, so what is this ridiculous number? Well, it was devised by Avogadro, and we call it N, the subscript capital A. This is Avogadro's number. Now, Avogadro's number, it's really just kind of devised so that the mass of something in grams per mole, that number is going to be the same as the atomic mass of that element. So, for example, carbon-12. You know that one carbon-12 atom has a mass of 12.00 atomic mass units. And we've devised it so that one mole of carbon, so 6.02 times 10 to the 23, carbon 12 atoms, that has a mass of precisely 12.00 grams. And so, you know, it's convenient, don't you think, that the atomic mass number, or the number of the mass of this atom in atomic mass units is actually the same number as the mass of one mole of that. So atomic mass is going to be the same number as the molar mass. Okay, so knowing that, we can actually start doing some conversions. So here's a problem. How many grams of potassium are there in 0.243 moles of potassium? Okay, so in order to do this, we need to use dimensional analysis again. We have to understand that 1 mole of potassium has a certain mass. See, how many grams of potassium per mole of potassium? So go to the periodic table and you'll see that the atomic mass of potassium is 39.10, and so therefore the molar mass is also 39.10 grams per mole. So having this equality, we're able to build two unit conversion factors. So 1 mole of potassium over 39.10 39.10 grams of potassium. This is one unit conversion factor that you might use, and another is 39.10 grams potassium over 1 mole of potassium. So now we can use these unit conversion factors to convert from those 0.243 moles of potassium into grams of potassium. Okay, so let's get out of moles and into grams. We need to get rid of these mole units and into grams. Okay, so we'll put moles of potassium on bottom, therefore it's on top and bottom, it cancels out, and we'll have grams of potassium on top. So we are going to select this unit conversion factor to plug in for our calculation. So 1 mole of potassium at the bottom and 39.10 grams of potassium at the top. And so 0.243 times 39.10 divided by 1. And so you should find that 9.50 grams of potassium should be produced. Now, just to prove to me that you are listening, I want you to go ahead and put a smiley face right by this box answer. And I want you also to have exclamation marks as eyes, okay? So just to show that you're doing it. All right, let's try another problem. How many atoms are in 0.523 grams of methane? How many atoms are in 0.523 grams of methane, CH4? All right, so in order to solve this problem, you probably want to understand this model. So ultimately, you know that you can go between grams and moles. So we just did that. But you can also go between moles and the number of either atoms, molecules, or ions of those moles of that thing. And if you have molecules, you can also go into atoms within all those molecules. This only works for molecules, however. Okay, so we need to go from, let's see, grams of methane. We have 0.523 grams of methane, and we want to go into moles of methane, then molecules of methane, then atoms of methane. And the reason that we want to go into molecules of methane and not atoms of methane immediately is that there are 6.02 times 10 to the 23 molecules of methane per mole of methane, not atoms. So testing this, let's see, grams of methane per mole of methane. How many grams of methane per mole of methane? So go to your periodic table, you see carbon, it's got a 12.01 atomic mass. And we know hydrogen, which we have 4 of, each one of them has 1.01. So we want to add the 12.01 to the 4.04, and we get 16.05. So 16.05 grams of methane per 1 mole of methane. Please note how I'm writing all of the molecules here. I'm writing my units and the molecules. It's important to keep track of what we're dealing with here. So we're converting from moles of methane then into methane molecules. If we have 1 mole of methane, that doesn't mean we have 6.02 times 10 to the 23 atoms. This is moles of this molecule, so we have 6.02 times 10 to the 23 molecules of methane. And from there, we can go from 1 molecule of methane finally into atoms. Okay, so how many atoms are there per molecule of methane? So methane is the following molecule. Let's see, we have 1, 2, 3, 4 hydrogens and 1 carbon. We have a total of 5 atoms. And so go ahead and calculate then the number of atoms of methane. So plug this into your calculator. Multiply 0.523 times 6.02 times 10 to the 23 times 5 and then divide by 16.05, and you should find that you get 9.81 times 10 to the 22 atoms. Okay? All right, very nice. I'll see you tomorrow.